In this video, we'll be introducing the limit concept of a function. When studying a function y equals f of x, we may need to consider a function's behavior near some number c, but not actually at c. For example, one situation in which limits can be helpful are when we need to evaluate a function at some number c that ends up making the denominator of that function equal to 0. To illustrate this idea, we'll consider the following example. How does the function f of x equal x squared minus 4 over x minus 2 behave near x equal 2? Well, to answer this question, we'll begin by simplifying the function by factoring the numerator as the difference of two perfect squares, x minus 2 times x plus 2 over x minus 2. Then we'll simplify by canceling the common factors of x minus 2 to get f of x equals x plus 2. Our function simplifies to the graph of the line y equals x plus 2. However, since the value of x equal 2 is not in the original formula for f, because it would make the denominator equal to 0, the function is not defined at x equal 2. That's why we write f of x equals x plus 2 for x not equal to 2. We'll modify the graph of the line x plus 2 to show that the function is not defined at that value x equal 2 by constructing an open circle or hole in the graph of x equal 2. Therefore, the graph of f of x is the line y equal x plus 2 with the point 2, 4 removed, which is represented by an open circle or hole in the graph. Even though f of 2 is not defined, we can make the value of f of x as close as we want to 4 by choosing values of x that get closer and closer to 2, as shown in this table. For example, if we substitute x equal 9, 1.9, into the original formula for f, we'll get 3.9. And if we substitute x equal 1.99, then we'll get f of x equals 3.99. And again, if we go 1.999 for x, then we'll get 3.999 for f of x. If you notice, as we get closer and closer to 2, the values of f of x get closer and closer to 4. The same will happen if we go from the other side of 2. If we start at 2.1, x equals 2.1 will give us f of x is 4.1. We substitute something a little closer, 2.01, we'll get something a little bit closer to 4, 4.01. And finally, if we plug in x equal 2.001, we'll get an even closer value to 4, of 4.001. So when it comes to trying to find the limit of this expression, we would write this as the limit as x approaches 2 of x squared minus 4 over x minus 2, which equals the limit as x approaches 2 of x plus 2, and that's 4. So this red 2 that we have over here, if x is 2, this value here approaches 4. When it comes to evaluating limits in general, we write limit as x approaches c of f of x equals L, provided the limit exists. I hope this helps. Don't forget to send us a like or subscribe. If you'd like to be included in future updates, let us know if you have any special requests by posting a message. Thanks.